You hear the term data science absolutely everywhere, right? It sounds so complicated, maybe even a little intimidating. But what if I told you it's really all about finding stories in the numbers, about turning raw information into smart decisions? Well, today we're going to pull back the curtain and demystify this whole thing piece by piece.
Okay, let's kick things off with this analogy because it's perfect. Picture data science as this incredibly sleek, high-performance sports car. It's powerful, it's fast, and it can take you amazing places. But what's really making it go? What's the engine under the hood? Well, that engine is statistics. It's the absolute powerhouse that takes the raw fuel, the data, and converts it into pure, unadulterated speed and insight.
So, here's our game plan for this explainer. We're going to start by breaking down the different fields that make up data science. Then we'll look at that mathematical engine that drives it all. We'll explore what it takes to be a data scientist, see what kind of problems this all solves, and then finally, we'll see how it's already showing up in your world every single day.
All right, first up, we're looking at data science as a cross-disciplinary field and its core components. And here's the most important thing to get right away. Data science isn't just one thing. Nope, it's actually a super powerful blend of a few different areas of expertise all working together.
In this chart, it lays out that blend perfectly. You've got three main pillars holding the whole thing up. First, you have statistics. This is the math, the rigor, the part that lets us model and make sense of data. Then you have computer science. This gives us the raw horsepower to actually process these huge amounts of information. And what's really cool is there's this kind of healthy tension between the two, right? But the piece that connects them, the absolute game changer, is that third slice, domain expertise. That's just a fancy way of saying you need to actually understand the world you're working in, whether it's retail or healthcare, so you can ask the right questions and make sure the answers actually matter.
So let's move on and pop the hood of that sports car. Section 2 is all about the mathematical engine, the real fuel that creates the insights. We're going to look at the core mathematical concepts that make that statistical engine run so incredibly well.
Now, I know this might look like a scary list from a math class you tried to forget, but stick with me because each piece has a really specific job. Think of linear algebra as the architect. It draws the blueprints for the machine learning algorithms. Calculus, that's kind of like the mechanic, fine-tuning the engine. It's used for this thing called gradient descent, which basically just means making tiny adjustments to the algorithm over and over until it gets incredibly good at what it does. Then we have probability, which is all about looking forward and trying to figure out the chances of something happening. And that's different from statistics, which is more about looking backward at the data we already have to figure out what it all means.
And while we're on the topic of statistics, you got to know about its two main flavors. On one side, you've got descriptive statistics. This is pretty straightforward. It's just about describing the data you have in front of you. You know, what's the average score? What's the highest and lowest value? It tells you what is. But then you have inferential statistics, and this is where it gets really cool. This is about taking a small piece of data, a sample, and using it to make a really good guess or an inference about a much bigger group. This is the part that helps us predict what could be.
So we've talked about the field, we've talked about the engine. What about the driver? That brings us to Section 3, the anatomy of a data scientist. Let's dig into the unique skills these people need and the step-by-step process they follow to actually get things done.
Of course, you need the technical chops. The math, the coding, that's all table stakes. But what separates a good data scientist from a great one? It's the stuff that isn't technical. They have to be incredible communicators, able to explain really complex ideas to people who don't have a background in stats. They need to be great at teamwork because they're always working with engineers and business leaders. And honestly, they need to be leaders themselves to drive a project from just an idea all the way to a real-world solution.
And this workflow shows you their playbook. Look at step 1. It's not about data, it's about understanding the business. That is the most important part. From there, it's a hunt for the right data to solve that problem. Then comes the heavy lifting, prepping the data and building the models. But it doesn't stop there. You have to actually get that model out into the world, deploy it so it can do its job. And then you close the loop. You measure to see if it's actually working, and you communicate those results back. It's a full circle.
Okay, on to our fourth section, the problems data can solve. We've got this amazing skill set and this rock-solid process, but what is it all for? Well, it's about one thing, turning all that messy data into clean, smart decisions. And this, right here, is the central problem that basically created the entire field of data science. Companies today they're practically drowning in data. They collect just unbelievable amounts of it. So the problem isn't getting data anymore. The real challenge is figuring out how to use it all to make better decisions and stay ahead of the curve.
So what kind of questions can we answer with this? Well, it's amazing at finding patterns you'd never see, like which specific server in a giant warehouse is probably going to need maintenance next month. It's great at spotting when something's off, detecting those weird deviations, like a credit card purchase that just doesn't fit your normal pattern. It can estimate probability, which is exactly how your favorite streaming service guesses how likely you are to watch that next show. And of course, it can categorize stuff, telling your computer if it's looking at a picture of a cat or a mouse.
All right, for our last section, let's make this all real. Section 5, Data Science in Your World. Because this isn't just some abstract theory, it is actively shaping the world around you right now.
I mean, just take a look at the range here. In retail, data science is scrolling through social media to predict the next hot product. For businesses, it's the engine that automatically places digital ads where they'll have the biggest impact. Governments are using it to forecast crime hotspots. And in finance, it's a critical tool for catching people who are trying to break tax laws. It's everywhere.
2 terabytes. That's 2,000 gigabytes. It's a staggering amount of information. Now, what do you think could possibly generate that much data in a single day? A giant corporation? A scientific research project?
The answer is you. That's roughly how much health data, from your smartwatch tracking your heart rate to glucose monitors, all of it, the average person generates every single day. It's an absolute flood of information. And data science is what helps doctors and hospitals monitor and analyze that flood, turning it into insights that can quite literally save your life. So we've seen that data science is this incredible mix of skills. It's powered by a mathematical engine, and it follows a clear path to solve huge problems in just about every industry, right down to our own health. And that leaves us with just one final thought. What about your world? What about your business or even your own life? What hidden patterns are just sitting there waiting to be discovered? What big questions could your data answer?